right, IM2 classes. Today we're graphing quadratics. We're going to start with basic quadratic, just an ax squared, where a is a whole number. It can, or not whole number, it can be just any real number, positive, negative, or fraction. Doesn't matter what it is, graph it all the same. So just, this looks like a mess here. This is out of the book. Really, all you need to remember is that when the A is positive, it's going to open up. Looks like a U. When the A is negative, it's going to be upside down like this. That's really what you need to remember from that. When the number in front of the x squared is positive, it opens up. When the number is negative in front of the x squared, it opens down. So let's go into an example. Real basic example here. First thing, what we're going to do to graph this is make a table. All right, I'm going to do a 3-column table. A lot of you guys could do this in your head, where this is going to be my x value, this will be my y value. In the middle, I'm going to show my work. And that's just going to help me keep things straight. First thing we're going to do is pick the domain. So the domain are x values that we're going to calculate. For these, when it's just an x, you're going to keep it real simple. It's going to be -2, -1, 0, 1, 2. So that is the domain I'm going to use to put, separate out this. So here, all I'm going to do is to figure out the y, I'm just going to square. So we're square the x. So -2 squared is a +4. Right here, -1 squared is a +1. 0 squared is 0. 1 squared is 1. And 2 squared is 1. And 2 squared is 4. And then here, this gives me my values that I'm going to plot. So I have 2, -2 and 4, -1, 1, 0, 0, 1, 1, 2, 4. Those are the coordinates of the points that I'm going to plot. So back to the pen, -2, 4. So that's -2 in the x direction. 4 in the y is here. -1, 1. So -1, 1. I do not know why it does that. This is very annoying. 0, 0. Nope. 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 Wow. Maybe if I do square points, is it going to do that stupid? Anyway, 1, 1, 2, 4. There we go. Now I'm going to connect the points with a nice smooth line, best you can. It's a parabola, right? So make a table. For the x values, for most of them, we're just going to do -2, -1, 0, 1, 2, and then calculate out the y. So here, let's do another one. I'm going to make my table. It's a very big table. I didn't need it to be this big, but that's okay. X, Y, and in the middle, I'm going to show my work. So I'm going to need -2, -1, 0, 1, 2. Plenty of space here. So here, what I'm going to do is I'm going to write the function. And I'm just going to replace the x with the set of parentheses. And then this will just help. I find when I do all this once, I make less mistakes. And then the parentheses, these x values are going to go in here. So -2, 1, 0, 1, 2. I'm going to go back and calculate it. So make sure you're using proper order of operations. So we got to do the exponents first. So -2 squared is 4. So negative 2 squared is a positive 4. So it's going to be 3 times 4. 3 times 4 is 12. 1 squared is 1. So it's going to be 3 times 1. 3 times 1 is 3. 0 squared is 0. So it's going to be 3 times 0. 3 times 0 is 0. And then here, these are going to be the same. So 3 times 1 is 3. 2 squared is 4. So we get 12 again. I forgot to write these. 3, 12. Right? So then plot the points. Negative 2, 12. It's off, so I'm just going to do my best to approximate that. Negative 2, 12 is up there. Negative 1, 3 is here. Negative 0, 0. Still 0, 0 right here. 1, 3 is here. And then 2, 12. So once we have them plotted, do your best, connect the dots. There we go. Next example, when we have a negative. So if you were paying attention to the that first slide, this is going to open going upside down. So we're going to have X, Y, and in the middle, we're going to put our work. So I'm still going to use negative 2, negative 1, 0, 1, 2. So here, negative 2 times x squared, 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 and then negative 2 times x squared, and go put in the x's. So that's the negative 2, negative 1, 0, 1, 2. Now go back through and calculate this out. So negative 2 squared is 4. So you get negative 2 times 4 is positive, no, negative 8. Negative 1 squared is positive 1. So negative 2 times 1, that comes out to negative 2. 0 squared is 0. So negative 2 times 0 is 0. And then these are going to be the same as up there. So negative 2. 1 squared is 1. So negative 2 times 1 is negative 2. Negative 4. 2 squared is 4. So negative 2 times 4 is negative 8. So plot the points. So negative 2, negative 8, negative 2. Oh, almost went positive 8. Negative 8 down here. Negative 1, negative 2. So negative 1, negative 2. 0, 0 is going to be here. 1, negative 2. And then 2, negative 8 down here. And that's it for there. All right. Next one. What to do with a fraction. So a fraction can be a little bit tricky, but what we're going to do is be a little bit smarter about picking our x and y points. So a fraction, we don't want to have to plot fractions. So what I'm going to do is pick points, pick the domain, the x values that are multiples of 4. So 1/4 is this, multiplying by 1/4 is the same thing as dividing by 4. So if I pick x values that are multiples of 4, when they get, then when I multiply by 1/4, we end up with whole numbers. We can think about it a little bit more. Oh, there's supposed to be a squared there. So y equals 1/2, not 1/2, 1/4 x squared. So I'm going to use 4, negative 4. Yeah, that's fine. Negative 4, I'm going to do negative 2, 0, 2, and 4. And what's going to happen when I square these and divide, it's going to come out to a whole numbers. So that's going to make it easy. So just give it a little thought about what your domain is going to be, and it'll make the graphing easier and make the math easier. You don't have to. You can pick whatever values you want. But if you give it a little thought, doing the math is going to be a little bit easier. So here it's going to be 1/4 x squared. So again, I'm going to write the function in here. Just replacing the x with parentheses. And I'm going to go back through and fill in those blanks of the parentheses with the x values. So -4 squared, -4 times -4 is positive 16. So I get 1/4 times 16. So again, multiplying by a fourth is the same thing as dividing by 4. So 16 divided by 4 is 4. So if we need to see that 1/4 times 16, make this a fraction, multiply straight across. 1 times 16 is 16. 4 times 1 is 4. 16 divided by 4 is 4. So that's how that works. But it's just the same thing as dividing by 4 here. So -2 squared is positive 4. So 1/4 times 4 is 1. 0 squared is 0. So 1/4 times 0 is 0. And then these are going to be the same as those top two. I'll do all of that. So 1/4 times 4 is 1. And then 4 squared is 16. 1/4 times 16 is 4. And I'll plot these points. So -4, 4. -2, 1, -2, 1. 0, 0. 2, 1. Right. I'm gonna fix that so my graph doesn't look like absolute garbage. And then 4, 4. So yeah, any x values will work, but if you think about it, calculating out these points is a lot easier, and then graphing is a lot easier. So give a little thought about what points you want to use for the x, your domain, when you have a fraction as part of the function. But that will do it for this time. Next time we're going to graph some more complicated functions.